Hello, everyone. I'm Harsh Patel, and I'm joined by my teammates Sim Parmar and Anton Palazo to discuss pea protein flavor removal by the process of ozonation. First, we'll be going through the purpose and scope of our project, and then we'll be giving some background information on pea farming and ozone gas, and then we'll be discussing experimentation conducted to understand oxidation characteristics, following which we'll be giving a brief overview on our process design, the projected economics, safety, and conclusions. So the purpose of this project, as outlined by our client, Dr. Lam of the Saskatchewan Food Industry Development Center, was to remove grassy flavors that consumers found undesirable using ozone gas. We were tasked to create a dry process to eradicate heating costs while keeping process safety as the main priority. So while dairy alternatives such as whey protein are amazing sources of protein, they require significant amounts of water to produce. 1 glass of milk has the water footprint of 30 gallons. In comparison, pea protein requires 0.16 gallons less water per kilocalorie of energy than whey protein, which would drastically reduce water consumption here in Saskatchewan. Research shows that pea protein market is on course to increase by millions of dollars in the following decade with applications in areas such as meat substitutes and dietary supplements. So now that you know a little bit about pea farming, I'll just be explaining characteristic behaviors of ozone gas to give better understanding of our process design. This gas can be produced very cheaply through a process called corona discharge and is currently used in food processing and water treatment industries for sanitation and odor removal. It's a very strong oxidizer and is toxic if inhaled.
So going over our experimentations and findings, first thing is to see how the pea protein is now in the market. And from the initial physical observations, we found that the taste was very grassy and the texture is to be soft and smooth. We also tried mixing it with water, and compared with whey protein, it is less soluble. So for the ozonation experiment, we did design an experiment, but we were unable to due to the COVID restrictions. We did, however, find relevant literature that supported our hypothesis. We found that hexanol was the molecule that caused the undesirable flavor, and that the ozone increased the degradation of these molecules, which results in a reduced flavor. We also performed a fluidization experiment to see how pea protein fluidizes and found that the powder is quite cohesive and it clumps up and sticks to walls. We plotted our data and found that the larger amount of flow rate is required for the whole system to be fluidized. So we decided to use a vibrating fluidized bed in our process to reduce the agglomerations. Going through a brief flow of our process, the dry air enters an ozone generator, turning oxygen into ozone, and then it's moved by a blower into the fluidized bed. The pea protein is fed by an auger hopper. Larger particles move horizontally through the fluidized bed and exits to a collector bin. The smaller particles suspended in gas enters a separation unit and collected in the collector bin. And the exiting gas from the cyclone can be recycled back to the system, and most of the exhaust exits from the collector bin through a filter.
And now for the economic analysis. After we performed it, we noticed that this process is very profitable. As we see in the table of the base amounts, we will be buying the pea protein at the cost of $2 per kilogram, and it will be supplied by AGT Foods. The selling price of the treated pea protein was decided to be $4 per kilogram, and we are aiming to produce 5 million kilograms per year. So the summary of cash flows was our capital costs initially would be 4.8 million. That would be to buy all the equipment. And then the total annual expense will be 12.3 million from our calculations, and the sale income projected will be 20 million. Our payback period would be of 1 year. So since ozone is lethal substance, so we had to do some safety considerations. As exposure to ozone, it can be lethal within the ranges of 0.1 to 5 ppm. There are risks of dust explosions due to agglomeration of pea protein, and so we need to watch out for those. There's also the potential environmental release, and federal regulations say no more than 0.063 ppm over an 8-hour period can be released. So the social impact, 77% of agricultural land is used for livestock. And if we reduce this land for growing livestock to at least half, we can produce about 200 and more plant-based products, and that can feed a lot more people. And then plant-based foods offer larger protein and caloric supply for less amount of food used. It also has a lower water footprint as animals use so much water, so dairy-based products actually have a giant water footprint. Pea protein is also very good for health, as It is similar to pea protein and provides similar functionality in individuals. It is allergen-friendly and a good alternative to soy and wheat proteins, as soy protein has high concentrations of phytoestrogen, making it less desirable for men. And also, it also helps people with who have type 2 diabetes, and it could be better for people with obesity. So the key points of our presentation were: it has a lower footprint than dairy products. The treatment reduces the grassy flavor, making the pea protein more consumable. The vibrating fluidized bed is required to reduce the agglomeration, as it is a very cohesive substance. It can be consumed by individuals who are intolerant to dairy, as people who are lactose intolerant. It is a healthier alternative to dairy-based substitutes. It also has a very high market demand. Thank you so much for your time. We hope you liked our presentation.